The solar system is a vast and complex network of celestial bodies that has fascinated astronomers and scientists for centuries. From the blazing sun at its center to the distant dwarf planets on its outer edges, the solar system is a wonder of nature that has inspired countless discoveries and scientific breakthroughs. At the heart of our understanding of the solar system is the science of chemistry. By studying the chemical makeup of the planets, moons, asteroids, and comets that make up our cosmic neighborhood, scientists can unlock the secrets of the solar system's formation and evolution. In this video, we'll explore the chemistry of the solar system from its origins to its present-day composition. We'll look at the role of chemistry in the formation of the planets, the chemical makeup of the Sun and its atmosphere, and the unique chemistry of each of the planets in our solar system. So sit back, relax, and prepare to embark on a journey through the fascinating world of the chemistry of the solar system. The solar system began as a cloud of gas and dust known as a nebula. Over millions of years, this nebula began to collapse under its own gravity, forming a spinning disk of material. As the disk spun faster and faster, it began to flatten out into a disk-shaped structure. At the center of this disk, the Sun began to form, while the material around it began to clump together to form the planets. The chemistry of this process was crucial to the formation of the solar system. As the material and the disk collided and merged, it released heat and energy, causing the temperature to rise. This heat caused the materials to melt and separate into layers, with the heavier elements sinking to the center and the lighter elements rising to the surface. This process, known as differentiation, is what gave the planets their distinct layers and compositions. The inner planets, like Earth and Mars, are made up of dense, rocky materials, while the outer planets, like Jupiter and Saturn, are composed mostly of gas and ice. By studying the chemical makeup of rocks and other materials from the planets and moons in our solar system, scientists can learn more about the conditions that existed during the formation of the solar system and how the chemistry of these materials has changed over time. In fact, some of the most important discoveries about the chemistry of the solar system have come from studying meteorites, which are fragments of asteroids and other celestial bodies that have fallen to Earth. By analyzing the chemical composition of these meteorites, scientists have been able to piece together a detailed picture of the early solar system and how it evolved over time. So while the formation of the solar system took place over millions of years, the chemistry of this process has left a lasting impact on the composition and structure of the planets and other celestial bodies in our cosmic neighborhood. At the center of the solar system is the Sun, a massive ball of hot, glowing gas that provides the energy that sustains life on Earth. But what is the Sun made of, and how does its chemistry affect the rest of the solar system? The Sun is primarily composed of hydrogen and helium, which make up more than 99% of its mass. But the Sun also contains trace amounts of other elements, including carbon, nitrogen, and oxygen. The chemistry of the Sun is driven by the process of nuclear fusion, which occurs in its core. In this process, hydrogen atoms are fused together to form helium, releasing enormous amounts of energy in the process. This energy is then transported through the Sun's layers by a process known as convection, which causes hot gas to rise to the surface and cooler gas to sink back down. The Sun's chemistry also plays a role in the formation of solar flares and other space weather phenomena. These events are caused by the release of magnetic energy stored in the Sun's atmosphere, which can cause eruptions of hot gas and charged particles that can affect the Earth's magnetic field and cause disruptions to our communication and power systems. To better understand the chemistry of the Sun and its impact on the solar system, scientists use a variety of tools and techniques, including telescopes, satellites, and spacecraft. By studying the light and other emissions from the Sun, as well as the particles and magnetic fields that it produces, scientists can gain a better understanding of the Sun's chemistry and how it affects the rest of the solar system. So while the Sun may seem like a simple ball of gas, its chemistry and behavior are incredibly complex and have a profound impact on the rest of the solar system. Each of the planets in the solar system has a unique chemistry that reflects its formation and evolution. From the rocky, terrestrial planets to the gas giants, each planet has its own distinct composition and characteristics. Earth, for example, is composed mostly of iron, oxygen, silicon, and magnesium, with smaller amounts of other elements like carbon, nitrogen, and sulfur. The chemistry of Earth's interior plays a crucial role in the formation of volcanic activity, earthquakes, and other geological phenomena. By studying the chemical makeup of rocks and other materials from Earth's crust and mantle, scientists can gain a better understanding of the processes that shape our planet. Mars, on the other hand, is a rocky, desert-like planet with a thin atmosphere composed mostly of carbon dioxide. Its surface is rich in iron and other minerals, which give it its distinctive reddish color. The chemistry of Mars is of particular interest to scientists because of its potential for supporting life. By studying the chemical makeup of the planet's soil and atmosphere, scientists can learn more about the conditions that existed on Mars in the past and whether or not it could support life in the future. The gas giants, like Jupiter and Saturn, are composed mostly of hydrogen and helium, with smaller amounts of other elements like methane and ammonia. The chemistry of these planets is driven by their massive size and gravity, which create intense pressures and temperatures in their interiors. The unique chemistry of the gas giants also gives rise to some of the most spectacular features in the solar system, including Saturn's rings and Jupiter's Great Red Spot. By studying the chemistry of the planets in the solar system, scientists can gain a better understanding of the processes that shape our cosmic neighborhood and the potential for finding life beyond Earth. The chemistry of the solar system is a fascinating and complex subject that has captivated scientists and astronomers for centuries. From the formation of the planets to the chemistry of the Sun and the unique characteristics of each of the planets in our cosmic neighborhood, the chemistry of the solar system has played a crucial role in shaping our understanding of the universe. By studying the chemical makeup of rocks, meteorites, and other materials from the solar system, scientists can unlock the secrets of the solar system's formation and evolution, and gain a better understanding of the potential for finding life beyond Earth. But the study of the chemistry of the solar system is far from over. With new technologies and techniques, scientists are constantly pushing the boundaries of our understanding of the universe and the chemistry that drives it. So whether we're exploring the planets in our own solar system or searching for signs of life on distant exoplanets, the chemistry of the solar system will continue to be a vital tool in our quest to unlock the mysteries of the universe. Thank you for joining us on this journey through the fascinating world of the chemistry of the solar system.